One of the main components is, as Barb said, is a gateway. And the basic concept of a gateway is it collects data from multiple sensors and communicates that via the internet to a web server and providing the sensor data. A good example of that is we want to measure the temperature of a freezer or a cooler. We put a sensor in the freezer or the cooler, and that gets communicated back up to our server through a gateway. The physical location of the gateway is going to be on the same site, same restaurant, same store as the sensors. So there's a couple different types of gateways that you need to know about, and they really affect the price of a system on an ongoing basis. And of course, for any solution, whichever way you choose, there's advantages and disadvantages. So the first one we'll talk about here is a wireless gateway. Typically, that's a cell phone connection between the gateway, a cellular provider, which provides access to the internet, and then it allows communication over the internet to a web-based server. From a cost basis, there's a cellular service element into the billing. The key advantage here is, and this is a major key advantage, is we don't have to get the IT groups involved. And from a location standpoint, it's easier to locate this gateway at an optimal location for the best radio pickup from the sensors. So really, there's no cabling involved other than AC power. So the other alternative is an Ethernet gateway. This basically eliminates that cellular billing, so there's a huge advantage in cost, but its disadvantage is you have to interface it through your internet router or your system, and that's going to typically require Ethernet cabling. And also your firewall is going to have to be configured to allow, our gateway to any gateway to communicate through your network to the IoT web server. We call this, there's a name for this, we call it whitelisting the firewall. So basically the gateway talks over the IoT server over an internet connection. And the second duty of a gateway is to communicate to the sensors. Placement of the gateway is important to get optimal coverage, of course, for the required sensors. So what's important for you to know? It's important to know how many sensors a single gateway can support. We've seen systems with as few as, supporting 20 sensors. So if you need 30 sensors, you need 2 gateways. And the secondary thing you need to be aware of is the radio technology used, because that's really going to depend how far you can support a gateway from a sensor. And of course, if that distance is beyond the technical capability of the radio, then you need to put in a second gateway or a third gateway. So basically what we've done in our product line is we've set up a process before a true install to decide how many gateways you need. Other considerations required for a gateway is, we want secure communication, so we use state-of-the-art encryption techniques, and so you got to look for that. And the other thing, I've heard that software engineers cause bugs every once in a while, so you want to be able to do an over-the-air type software upgrade with a simple button push or to upgrade all these sensors. You have thousands of sensors in a network in an Internet of Things monitoring system. The heart of the system is, of course, the sensors, and a sensor is just that. It collects desired data. The data that the sensor collects, it's communicated to the web server via the gateway, as you saw in the prior slides. One of the main considerations in sensor selection is the physical environment. So if it's a very wet environment where you're spraying hoses and cleaning and you got a lot of water, you need an industrial grade sensor that's watertight. If it's a dry environment and maybe just once in a while a damp cloth for cleaning, you can go with a lower cost alternative in a commercial grade type sensor. So there's physical environment considerations for what sensors that you need. And of course, there's various types of sensors, temperature, humidity, if your door on your walk-in coolers is open or closed, we basically motion, and then like a simple push button can detect also. The other thing to talk about sensors is the interval of frequency of the data collection. So, typically this is a trade-off between battery life. You don't want a situation where you got your sensors hardwired to power. You want to use battery technology so they're free of cabling. And typically you can get over 2 years of battery life, in some cases well over 5. And if I really do the math, I can have some sensors based on over a 10-year life of battery, based on a low frequency of detection.